So in physics, how can we define work? Work is basically the effort we are applying for the motion of an object. For the displacement of an object, we are taking some effort. For example, there is a table on a rough surface. There is a table on a rough surface. If I push it, what happens? It will move. It will cover some displacement. Clear? It will have some displacement. So the how much effort I have done, the more force, the more effort I have taken. Understood? The more force means more effort I have taken. Not only force, the displacement also has a role. The more displacement of the turbo, the more effort I have taken. So connecting F and D, we are making a formula for work. So very simple. The more force means more effort we are taking. The more displacement of the body means more effort I have taken. So the force, so using this concept, I am going to define work. Okay, using this concept, I am going to explain the concept work. Suppose there is an object, it is placed on a surface. Suppose I am applying a force. Okay, I am applying a force. Suppose, let me start with a simple case. I am applying a force like this, horizontally. I am applying a force F. As a result, the body has got a displacement. The body has got a displacement, say D. The body has got a displacement, say D. I am starting with a simple case. The more general case I will discuss later. So the force F I applied horizontally. As a result, the body has got a displacement. So the work in physics, the work is defined as the more force, more work. The more displacement also means more work. So connecting these two, the work is defined as F into D. This is the simplest formula if F and D has same direction. If they have different direction, there is a small change in the formula. I will discuss it, don't worry. If F and D have same direction. So work is equal to force into displacement. Work is equal to force into displacement. Then this is the way we define the work. So what is the unit of work? The force has the unit Newton. Displacement has a unit meter. Newton meter is a unit, one of the unit, Newton meter. It is defined as joules. The unit of work is defined as joules. It is also a unit of energy. Work means we are spending energy, understood? We are utilizing our energy. So the energy and work both having the same unit. Work means we are utilizing our energy for the motion of the body, understood? So all of you please write down. Please remember the formula. Work equal to force into displacement. The force and D have the same direction. If F have a different direction, I will discuss. Okay, don't worry. So all of you please write down. If you have written and understood, raise your hand. Raj, I started a new chapter. Raj, you are a little bit late. I started 5th chapter. Okay, I started 5th chapter, work, energy, power. ആര്യൻ മനസ്സിലായല്ലോ അല്ലേ? ആര്യൻ. ബെറ്റ്സി, ഞാൻ പേര് വീണ്ടും മറന്നുപോയി, ഒന്നുകൂടി പറഞ്ഞേ. ആഷ്ലിൻ. ഓക്കെ. ആഷ്ലിൻ മനസ്സിലായി ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കണം കേട്ടോ ആഷ്ലിൻ ഓക്കെ ദേവശ്രീ you understood. If you have written, please raise your hand. This is the simplest case, okay? This is what? The simplest case. All of you please listen. All of you please listen. Then you will have a doubt. If f and d do not have any, I mean, f and d does not have a same direction, what will we do? Then I will discuss. If f is a vector quantity, right? And d do not have same direction. But in most of the numerical questions, f and d will have the same direction, right? But if and d do not have same direction, what we can do? Same direction. For example, there is a body which is restricted to move in the horizontal direction only. There is a body placed on the surface. The body can move only in the horizontal direction. The body cannot move like this. It cannot fly. In whichever direction you apply force. Understood? In whichever direction you apply force. For example, it is a table. Understood? It is a table, heavy table. Whichever direction you apply force, the table is restricted to move in the horizontal direction. It cannot fly like this. It will not fly like this. So my general case is, what happens if f and d do not have a same direction? For example, I am pushing the table like this. I am applying a force like this, making some angle with the horizontal, right? Do you believe that the table will be moving like this? Will the table will be moving like this? No. The table is restricted to move horizontally. Understood? It cannot fly. So as a result of this force, the table has got some displacement, say d. As a result, it has got a displacement d. In this case, what we can do? We have taken some effort, understood. What work I have done for the movement of the table, understood. For the motion of the table, what effort I have taken? That is the question. Have you understood the situation? Is that okay? Clear? Said, Deva, all of you clear? You understood?
Yes, sir.
Okay. So if f and d do not have a same direction, in this case, suppose f and d make an angle theta. Suppose there is an angle theta between f and d. Some angle theta between f and d. So in this case, what happens is, some force, I mean, you know that in the previous chapter I have discussed. Okay, in the previous chapter I have discussed, I think you still remember that. F is an inclined force, right? F is an inclined force. F has two components. F has two components. What are the two components of forces? The two component of forces, let me draw here. The two component of forces, F has a horizontal component. I have already discussed that. If you don't remember, just memorize this. F is an inclined force. F has a horizontal component, F cos theta, and F has a vertical component, F sin theta. Actually, I discussed during, I mean, projectile motion. When I discuss the projectile motion, I have already discussed the horizontal and vertical components. I mean, if the body is projected with a velocity u, the horizontal component is u cos theta, vertical component u sin theta. So in the same way, if I apply a force making some angle with the horizontal, horizontally how much force felt by the body? The body experienced some horizontal force as well as the body experienced some upward force. Due to F, understood. Due to F, the body experience two simultaneous forces. The body apply a horizontal push. Because of this F, the body, I mean table, experience some horizontal push. It has a magnitude F cos theta. And because of this force, the body experience some upward force, understood? Upward push. The body experience some upward push, but due to the weight of the body does not move upward because of the weight of the body. So the body experience two simultaneous forces. One is F cos theta horizontally, other one is F sin theta. But F sin theta does not have any role because of the weight of the body. The body does not go up. Understood? The body still lie on the ground. But because of F cos theta, the body has some tendency to move horizontal direction because of F cos theta. So if you don't remember, please memorize. If you have a vector, whether it is force or displacement or velocity, whatever it may be, the vector will have two components or two parts. Horizontal component is that one into cos theta. Vertical component is that one into sin theta. I discussed in the projectile motion. So if you don't remember, at least memorize right now. Horizontal, that vector into cos theta. Vertical component will be that one into sin theta. Is that okay? Clear? Said, Aryan, Deva, Aaron, all of it clear?
Yes, sir.
Okay. Now tell me, what is work? The work for the movement of the body. The upward, in the upward direction, I am taking some effort, but that effort becomes a waste. Waste means the weight does not allow the body to move upward. So some part of the work is lost. Some F sin theta does not have any role for the movement of the body. The body is moving only because of F cos theta, right? The body is moving horizontally only because of F cos theta. F sin theta does not have any role. The body even does not move upward. So F sin theta is a waste, let us say like that. So in this case, what is the useful work? Useful work means the work for the movement of the body. Force, what is the work done? The force, horizontal force into horizontal displacement. This formula. Work done equal to force into displacement, right? Work equal to force into displacement. Means the horizontal force into horizontal displacement. Horizontal force into horizontal displacement. The horizontal force is F cos theta here. F sin theta is not counted. Does not have any role. The horizontal force into horizontal displacement. So this is the general situation. So in this case, work equal to F d cos theta. This is the general formula. We use this formula only if there is some angle between F and D. If there is some angle between F and D, we will use this formula. But normally the simplest case, most of the question contains the simplest case. Horizontally we are applying force. As a result, the body moving horizontally. So cos theta will not come here, only F into D. If there is some angle between F and D, Fd cos theta is the formula, understood? So all of you please write down this general case also. If you have written and understood, raise your hand. ആഷ്ലിൻ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കണം കേട്ടോ. ആഷ്ലിൻ ക്ലിയർ ആയില്ലെങ്കിൽ. If you have written and understood, raise your hand. Devasri understood. Devasri, if you have any doubt, please ask me.
Yes, sir.
1 minute. All of you have finished? Devasri, have you completed?
Yes, sir.
Okay. Please raise your hand if you have written. Let us look at a simple question. Let us look at a simple question. Okay. And listen, the first formula only if f and d in the same direction. Okay. So all of you please listen. This is a simple question taken from textbook. Example 5.3. It is a solved example given in textbook. It's a very simple question. A cyclist come to a skidding stop in 10 meter. I will read again. A cyclist comes to a skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton and is directly opposed to the motion. How much work does the road do on the cycle? How much work does the cycle do on the road? You can draw a rough diagram, then only you can understand the question. Okay.
Sir, is this question there in the textbook?
It is taken from NCERT textbook.
Okay,
All of you please listen. All of you please listen. So if you don't draw any diagram and simply read it, you will not be able to start. You will not be able to start if you don't draw any some rough diagram. So some rough diagram, cycle. No need to draw a proper cycle. Let it be cycle. Understood? This is the rough surface, ground. Understood? This is a cycle. The cycle is moving like this, but because of the friction, understood, the road is not so smooth. The road is not so smooth. After traveling how much? 10-meter displacement. The cycle stop here. Understood? It has some initial velocity, but because of the friction of the road, the cycle stop after traveling 10-meter displacement. So the road is applying a friction is there. The friction prevent the cycle. I mean the friction reduces the speed. You know that the friction is a force applied on the cycle. The force applied on the cycle is this direction. F is equal to 200. You know that F is a remember the theta is not there, right? Theta is not there, so cos theta will not be there in the formula. If theta is not there, then cos theta will not be there in the formula. But if the force is towards right, positive sign to be given. If the force is towards left, the negative sign to be given. Please don't forget to put the sign. Both are vector quantities, right? So if the force towards right, you have to put a positive sign. But here the friction means it is towards left, against the motion, right? F equal to minus 200. If you simply write 200, you will not get any mark in the exam. Okay, so F is minus 200. Force is the friction force backside, but displacement is plus 10. Understood? Displacement is plus 10. The motion is towards right. Cos theta will not be there. Theta is not there, right? So now I want to find out what is the first question. Let me complete it. Let me complete it. After that, you can ask me doubt. Let me complete it, the first question. How much work does the road do on the cycle? The road is doing some work because this force is done by the road. Understood? The friction provided by the road. So road has done some work on the cycle to stop it. So road has taken some effort. So work done on the cycle. Understood? Work done on the cycle. Who has done the work? Road, right? Road has done some work. How much force applied by the road? Force into displacement. Cos theta will not be there. Force into displacement. Work done. Force is minus 200. Displacement is plus 10. Force into displacement. If force and displacement horizontally, force into displacement. If theta is there, cos theta to be included. So minus 200 into 10, minus 2000 joules of work done by the rod on the cycle. The negative sign indicate that the work is done to stop. Understood? I mean, the negative sign indicate that the force towards left. Understood? Negative sign of the work means that the force in the opposite direction of the displacement. So all of you please write down. The first part is done. The first part is done. All of you please write down. If you have understood and written, raise your hand. Raj, you can ask me doubt, Raj. Say the Aaron, Aryan understood. Devasri understood. ആഷ്ലിൻ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കണേ ആഷ്ലിൻ.
Okay, sir.
Everyone, okay, understood. Second part is a tricky question. Second part is a tricky question. How much work does the cycle do on the road? Anybody? How much work does the cycle do on the road? Cycle applying some force, maybe applying some force, but the road does not move. Understood? The work will be present only if there is some displacement. How much work does the cycle do on the road? Is the road moving? Because of the cycle, is the road moving? No. Road does not move. Road has zero displacement. Let me write all the proper steps. Road has zero displacement. Cycle may or may not be doing some force, applying some force. Cycle may or may not be, whatever, may be applying some force, but road is not moving. The work will be there only if some displacement. Understood? If I am applying some force but no displacement, I am applying some force on the body, on the table, but the table is not moving. What work I have done? I have done zero work. The displacement should be there. For the work, the displacement should be there. Because force into displacement. If displacement is zero, no work. So the cycle is applying some force, maybe applying some force on the road, but the road is not moving. So the work done on the road will be zero. Work done on the road. If the road is moving, okay, some work is done on the road. Work done on the road will be zero because the road does not have any displacement. So 0 joules. It's a tricky question. So all of you please write down. If you don't understand, please ask me. Aaron understood. Aryan, Devasri understood. Raj, okay. Ashlyn Said understood. Okay. So it's taken from textbook. So next one. Okay. So the work is clear. Understood. Force into displacement you have understood. If theta is there, formula will be ft cos theta. There is no question for that. So now let me introduce energy. So work is actually the converting my energy into understood. Work is actually energy, right? I am pushing the body means I am utilizing my energy. Understood. So let me explain about the energy. Okay, I am using my energy. So work is another form of energy. Understood. So the next is there are different types of energy you studied in the lower classes, like kinetic energy, potential energy, like that. The thermal energy, understood? Sound energy, there are plenty of energies. So among these energy, the most important energy is kinetic energy. There are different types of energies. Among the different type of energy, the most important type is kinetic energy. In our syllabus, only two types of energy we will learn: kinetic energy and potential energy. But potential energy we will learn later, not right now. For the time being, we are going to learn kinetic energy. Have you heard about kinetic energy? Anybody? Have you heard about kinetic energy?
Yes, sir.
What do you mean by kinetic energy? Anybody?
If the body moves, it contains energy.
Ah, yes, yes, yes. For example, there is a body, some body having some mass, a body having some mass, and it has a velocity v. Then the body possesses an energy, right? Why it possesses or contain energy? Because if this moving body hit any object or hit me, I will feel the pain. Understood? If this moving stone, suppose this is the stone having mass m and velocity v, if this stone hit on me, I will feel the pain. So the every moving body possesses some energy, right? Understood? So the understood. Every moving body we possess some energy that is said to be kinetic energy. Understood. Definition is only formula is required. Understood. Proper definition is not required. So every moving body has certain energy that is kinetic energy. So suppose mass equal to m, velocity equal to v, we define kinetic energy as. Its proper derivation is not there in our syllabus, but we define the formula like this for for explaining work energy theorem. The proper derivation of kinetic energy is not there in our syllabus. The proper derivation of kinetic energy is not there in our syllabus, so I don't want to derive it. If the body has mass m and velocity v, the kinetic energy, it is denoted by the letter k, capital letter K. It is defined as half mv square. Remember, I am telling you the derivation of this formula is not there. But actually we develop this formula for explaining work energy theorem that I will discuss later. So every moving body has certain energy that is said to be kinetic energy. If mass equal to m and velocity equal to v, the kinetic energy is defined as half mv square. Unit is joules. Joules. Symbol is J. All of you please write down. All of you please write down. If you have written and understood, please raise your hand. Aaron, Aryan understood. Devasri okay. Ashlyn okay. Raj okay. Aryan say that everyone is clear. Okay. I will discuss all varieties of question based numericals. I will not skip any type of question. Okay. Numerical I will discuss. It is taken from solved example given in textbook. Okay. Exercise also I will discuss. All of you please listen. It is taken from the solved example. I will discuss. All of you please listen. It is about kinetic energy. Okay. This question is about kinetic energy. I will read it. In a ballistics demonstration, a police officer fires a bullet of mass 50 gram with the speed 200 meter per second on soft plywood of thickness 2 centimeter. The bullet emerges with only 10% of the initial kinetic energy. What is the emergent speed of the bullet? So actually most of the students find it very difficult to solve numerical because they simply read it. They don't even draw any rough diagram. That's the main reason they are unable to solve the numericals. At least draw some diagram. Okay, you need some starting. In a ballistic demonstration, a police officer fire a bullet, 50 gram, okay. Mass of the bullet is 50 gram, speed is 200. Soft plywood of thickness 2 centimeter. Let me draw a plywood having some thickness, okay. Whatever, 2 centimeter, okay. I mean, in some questions, all the data may not be useful. Some data is not required, okay. This is the plywood having thickness 2 centimeter, okay. A bullet is fired on this plywood. Just before hitting the plywood, its initial velocity, mass of the bullet remains the same, right? Mass of the bullet is what? 50 gram. 50 gram will be 50 by 1000 kilogram. Our unit is kilogram, right? Mass of the bullet is 50 gram. It should be converted to kilogram. 50 by 1000 kilogram. The initial velocity, let me denote by v1 or u, also you can use. Just before hitting the plywood, the velocity was 200 meter per second. Just before hitting the plywood. All of you clear? Till this step you are okay? Aaron, Aryan, Deva, Ashlyn, Said, have you? Okay.
Yes, sir.
After hitting the plywood, what happens? Its speed will be reduced. Understood? Clear? Because of the friction and other kinds of forces. Frictional forces. The bullet will emerge out of this plywood. Understood? The bullet will cross it. The thickness is only 2 centimeter. 2 centimeter, right? Clearly mentioned in the question that bullet crosses. The bullet crosses the plywood, but the velocity will not be same as the initial speed. Final velocity we don't know. Let us assume that it is v2. The final velocity will be far less than 200. Understood? Emerging speed. So the question, but mass remains the same. Okay, mass does not vary. Mass of the bullet. The question says that the bullet emerges with only 10% of the initial kinetic energy. So the question says that the final kinetic energy K2, the kinetic energy after emerging out of the plywood is K2. The kinetic energy before hitting the plywood is K1. K1 and K2 are the kinetic energies, initial and final. The question says that final kinetic energy is equal to 10% of K1. Understood? It's mentioned in the question. Final kinetic energy is only 10% of initial kinetic energy. All of it clear? Is that okay? Understood?
Yes, sir.
Okay, there was 3.
Yes, sir.
Okay. So K2 equal to 10% of, you studied in the lower classes, percentage of a number. How will you find a percentage of a number? 10% means that 10 by 100. Understood? 10% means that 10 by 100. Of K1 means into K1. Understood? Studied in the lower classes. Percentage of a number multiply with that number. 10 by 100 into K1. Now, kinetic energy. What is the formula of kinetic energy? Kinetic energy is half mv square, right? So final kinetic energy equal to half into mv square. mv2 square, understood? The final velocity is v2. So the final kinetic energy is half into m into v2 square. The mass does not change. Let me complete it. After that you can ask me doubts. 10 by 100 will be 1 by 10. Simplification. 10 by 100 is 1 by 10 into K1. K1 is the initial kinetic energy. Formula for kinetic energy is half mv square. So K1 is half into m into v1 square. Half mv square. K1 is the initial kinetic energy. So half into m v1 square. Okay. Till this step, all of you clear? Till this step?
Yes, sir.
Said everyone okay? Raj,
Yes, sir.
Devasri, everyone is okay. Can I delete any term, left side and right side? Can I cancel any term? 1 minute, let me connect the charger, 1 minute. Can I cancel any term? Look here, 1 by 2, 1 by 2 cancel, left side and right side. M cancel, left side and right side. If you see same number left and right, I can cancel. So only V2 square is remaining in the left side, and right side is 1 by 10 into V1 square. Other terms cancelled. Hi, what is our question? V2 is our question, right? What is the emergent speed? The final velocity is our question. V1, what is that V1? V1 is 200, correct? So V1 square will be 200 square. 200 into 200. 1 0, okay, cancelled. V2 square is equal to 2 into 2, 4. 4000. But I want the V2, so I have to take the square root. Root to 400 we can write, but 10, I don't know. Can I write 4000 as 400 into 10? Understood. 4000 is 400 into 10. Try to simplify. Root to 400 is 20. 20 square is 400, right? I think in the exam, if the question is asked, they will at least give the value of root 10. Okay. I think it is 1 minute. It will be given. Okay. Otherwise, you need not simplify. Otherwise, you need not simplify. Root 10, 1 minute. 3.1. 3.2. Suppose it is given. So root 400 is 20 into root 10 is there, which is 3.2. So what is that? 64 meter per second. The initial velocity was 200 meter per second, but after hitting the plywood, the velocity will be only 64 meter per second. So all of you please write down. If you are okay, 100% clear and written, raise your hand. Please remove your old raise hand. ആഷ്ലിന് മനസ്സിലായി എന്ന് വിചാരിക്കുന്നു. ആഷ്ലിൻ
Yes, sir.
ആയിരം കഴിഞ്ഞാൽ പറയണം കേട്ടോ. സെയ്ദ് everyone is clear. Said okay. Okay, all of you clear, understood. So we can go to the next then. Finished. Okay. Now we are going to learn an important theorem. So we studied kinetic energy. Every moving body will have a certain energy. Okay. Now we are going to learn one important theorem. It's a very, very important theorem. Work energy theorem. Its derivation is important. Work energy theorem. Work, I have explained the effort we are taking for the motion of a body. Energy here stands for kinetic energy. In this title, the energy stands for kinetic energy. There is a connection between work and kinetic energy. There is a connection between work and kinetic energy. That theorem is said to be work energy theorem. I will discuss it. The derivation is there. Let me start with a simple case. Suppose a body having mass m. Suppose there is a body having mass m. It has an initial velocity, say u, or v1, whichever letter you may use. It has an initial velocity u. And here I am applying some force. Here I am applying some force. If a force is not there, it will be moving with the same speed. The acceleration will not be there. Understood? If I am not applying any force, it will not have any acceleration. So I am applying some force. As a result, the body is moving like this, and the body reaches this point. The mass remains same, the final velocity at the time of observation. At the time of observation, the velocity has become v. Okay. During that time interval, the body has got a displacement. During this time interval, the body has got a displacement, say S or D, or you can use any letter. Okay. So till this step you understood. I am applying a force. The body mass is m, initial velocity u. I am applying a force, and final velocity becomes v. And during this time interval, the body has got a displacement s. Okay. Till this step you are okay.
Yes, sir.
Okay.
Yes, sir.
Now all of you please listen. What is the work done? Work is equal to the simplest case I am discussing, force into displacement. The force and displacement both are in the horizontal direction. So a force into displacement, F into S, correct? F into S. Just 1 minute. Just 1 minute. There is no mistake. Just wait. Before this, okay, there is no mistake in this, but I will use it later. Okay, after 1 or 2 steps I will use it. In the motion, kinetic motion, I mean not kinetic motion, you studied in the motion in the which chapter? Motion along a straight line. Okay, in the chapter motion along a straight line, you studied this formula. Let me begin with this formula: v square equal to u square plus 2as. Do you remember this formula? All of you, do you remember this formula? V square equal to u square plus 2as. Aryan, Ashlyn, Asaid, do you remember this formula?
Yes, sir.
Yes, sir.
Okay. So let me do some rearrangement. I am starting the derivation from this formula. U square is taken to left hand side. U square is taken to left hand side. V square minus u square equal to 2as. V square minus u square equal to 2as. Let me write it again. Let me just write it again. Now let me multiply left side and right side. If I multiply same number, there is no mistake, right? Left side and right side, I am multiplying with the half m. I want a formula for kinetic energy. That is the reason. I am multiplying left side by half m. If I multiply left side by half m, I must multiply right side also by half m. Understood? If you multiply same number both side, there is no mistake. So left side I multiply with a half m. So right side also I multiply with a half m. Understood? I want the formula for kinetic energy. That's why. In the left side I can open the bracket. In the left side I can open the bracket. I will get half mv square minus half mu square. And in the right side, you know that 2 cancels, correct? 2 cancels. ma into s. ma, let me put a bracket, mas. Is that okay? All of you clear? Till this step you are okay? Aryan, Ashlyn, Said, all of you clear?
Yes, sir.
This derivation is important. It's a very simple derivation. Right side. In the chapter laws of motion, or even in 9th standard you studied mass into acceleration. The body has some acceleration a. Mass into acceleration is the force we are applying. Understood? We are applying force continuously till the end point. Mass into acceleration is actually force, right? So right side is ma is actually force. So F into S, right side is F into S. Force into displacement, right side. And the left side is half mu square half mv square minus half mu square. What is this F into S? F into S is the work done, understood? The force into displacement, correct? It is the work done. What is this half mv square? Half mv square is the final kinetic energy. We can denote like this, kf. F means final. Kf is the final kinetic energy. Half mu square. Half mu square is the initial kinetic energy. Actually, this is very important formula. In some questions, we require this formula. So work done. What is so our conclusion? I am writing my conclusion. The work done is force into displacement. That is correct. The work done is also equal to change in kinetic energy. Change in kinetic energy. This is said to be work energy theorem. Only this much. Work done is equal to change in kinetic energy. Meaning that final kinetic energy minus initial kinetic energy. Just subtracting, understood? Just taking the difference of final kinetic energy and initial kinetic energy, we can find out how much work is done by the external force. Understood? So it is said to be work energy theorem. Okay, so all of you please write down. This derivation is important. It's a simple derivation, so please write down. If you are okay, return, raise your hand. Aaron, Aryan, Devasri finished. Ashlyn writing, right? Say the
Yes, sir.
okay, okay. The work done by a force, okay, is equal to the change in kinetic energy. Say the you are still writing.
Yes, sir.
Okay, okay. Ashlyn completed.
Yes, sir.
Okay, everyone finished. This is a important question, but I will discuss this question in the next class. It's a exercise question. And even in JE exam, have you heard about JE exam? It is a highly competitive exams for the admission into NITs. Actually, there are plenty of questions based on work energy theorem. The question you see on the screen, it is actually JE question. It is just based on the work energy theorem. The same model question is there in NCRT also. Okay, this NCRT question and this one is very similar, right? Very similar. So but I will discuss this problem in the next class. Okay, so today you understood the work energy theorem, and I think it is better to discuss the graphical method and everything in the next class. So I think for the time being, let me wind up the class. So this problem, it is better to discuss in the next class. Okay, and graphical method of finding work is the, then potential energy is the potential energy, the, and many other things. Okay, all these things we will learn in the next class. So do you have any doubt in today's class? Today's class is clear to you, right?
Yes, sir.
Okay, then let me wind up the class then. Okay. Okay, let me leave. If you have written, you can leave. Okay.